Good morning friends. Today in this video I will be showing you how to solve the polynomial questions. This is the second chapter from ncert class 10 max. So we will look at the examples and exercises belonging to this chapter in this video. And so first we will start. If you like this video, please subscribe it, and if you want to share it, please share it. And so now we will move forward. Alpha and beta are the two concepts, that new thing that you are going to study over here. Alpha and beta nothing but the zeros of the polynomial. Now what is the zeros of the polynomial? First we will take an example. For example, x square plus 7x plus 10. Now here you have to find the zeros of the polynomial. Zeros of the polynomial, to find it is very simple. I will explain you how to do that. Now sum of the zeros. So the sum of the zeros are nothing but the resultant of this. For example, now if I solve this, you will know. Now how to solve this equation? It's very simple. This is nothing but sum. Now if we keep this as a and b and c. Now in this equation, the how to solve this is, b should be always the sum of the two numbers. Sum of two numbers. That means, for example, 2 plus 5, 7 you will get. And c should be always product of two numbers. Same two numbers which you are taking over here should be same. For example, product of two numbers. So this two numbers should be same. For example, if you take 2 and 5 over here, here also 2 and 5. So sum of two numbers should be b and the product of two numbers should be c. So sum of two number should be b, means 2 plus 5, for example, if you take, means it is 7. 2 plus 5 is nothing but 7. And 2 into 5, same 2 into 5 number is 10. And 2 into 5 is nothing but 10. In the same way, you got this. Now if we write it down in the equation, how it will be, I will show you. X square, it will be x square plus 2x. 2 and 5 means that variable should remain same. For example, 2x means 2x only it should be. 2y means 2y only it should be. 2x plus, because adding we are here only addition. Here it is multiplication. 2x plus 5x plus 10. 10 should be remain same, because here it is 1 actually. So 1 into x square is nothing but x square. That's why they didn't add 1. So but we will assume it as 1. And 1 into 10 is nothing but 10 itself. That is the product of the number. So now we will go forward. So x square we will keep it instead of 1x square, because it is same. 2x bracket we can put plus 5x plus 10 we can put in bracket. X we can take common outside, so it will inside it will be x plus 2, because here also x and x common, so here outside it will be x. So that's what we did over there. And plus 5 into x plus 2. So x plus 5 into x plus 2. So these are the zeros of the polynomial. X equal to minus 5, x equal to minus 2, x equal to minus 2. So now zeros of the polynomial means the value of the x which you are getting. For example, zeros of the polynomial here in this case means zeros of the polynomial is minus 5 comma minus 2. Now zeros of the polynomial, in this case we will represent, if we do not know the zeros of the polynomial, we will represent it as alpha beta. So sum of the zeros we will calculate first. is alpha plus beta equal to minus 5 plus minus 2 minus 7, and product of the zeros alpha beta, that is alpha into beta, we can represent this alpha beta, it will be 10. Minus 5 minus 5 minus plus 10, minus into minus is nothing but plus. So now we can observe over here one more thing, that sum of the product, that is alpha plus beta is same, is except the sign it is similar to the b of our equation, that is this one. So now we will look how it is same and what is the relation between them. This minus 7 and this 7 are same, that means we can equate it as alpha plus beta equal to, here it is 1, since it is 1 we can equate it as alpha plus beta equal to minus b by a, because here minus here plus 7, so it will become minus 7 by 1 is nothing but minus 7, and we know that alpha plus beta we already got as minus 7 itself, here minus also here. So in this way it is interlinked. And now alpha beta we will see how it is interlinked. Alpha beta is same as c itself, so it will be alpha beta equal to c by a, because a is nothing but 1, so nothing, no change is going to take place, so it will be 10 by 1 equal to 10, that is same as this 10 is same as this 10. Therefore we can say that alpha plus beta is nothing but minus b by a, and alpha beta is nothing but c by a. So these are the two equations that it is very important to study. And one more equation like this type is given in your textbook, that is the alpha beta gamma, that is the another one. There are three zeros, that is not necessary in our syllabus. It is also given that not from the examination point of view, so it is not necessary to study. So now we will look at the first example, that is example number 2, because example number 1 that is in graph. So example number 2 we will look, which says that is same as the question which we solved, that we have to find the zeros of the polynomial. Now we will look at example number 3. It says that find the zeros of the polynomial x square minus 3 and verify the relationship between zeros and coefficient. Find the zeros of the polynomial. So x square minus 3 and verify the relationship between the zeros and the coefficient. So verify means you have to check that alpha beta is equal to minus b by a or not, and alpha beta equal to c by a or not. So x square minus 3 we can also write it as, we know that a square minus b square is nothing but a plus b into a minus b. In the same way a square minus b we can write it as like this. So it will be x minus root 3 x plus root 3. So now we got that equation. Yeah, so now we can easily get the zeros of the equation, that is x square, x equal to root 3 and x equal to minus root 3. This is 0. So first you take this equation and solve, you will get plus 3. You will take this equation and solve for x, you will get minus 3. So now you got. Now we will go further. That zeros of the polynomial are nothing but zeros of the polynomial are nothing but root 3 alpha plus b or root 3 and minus root 3. Now you have to check whether alpha plus beta equal to minus b by a and alpha beta equal to c by a or not. For this to check, we have to use the formula alpha plus beta. For that you should not write it as minus b by a. First you have to solve alpha plus beta, then solve minus b by a, then check whether they both are equal, then say that alpha plus beta equal to minus b by a, hence verified. Now for the second part also same like that. So alpha plus beta is nothing but plus root 3 minus root 3 is nothing but 0. Thus we know that 1 minus 1 equal to 0, 2 minus 2 equal to 0. In the same way, plus alpha plus root 3 minus root 3 is nothing but 0. And now now b minus b by a. Minus b by a, if you look at the top thing, we can see that b is nothing but 0, because x square plus 0x minus 3 is nothing but x square minus root 3 minus 3. So here no x is there, so it will be nothing but b equal to 0x. So we are taking only the coefficient, so it will be 0. So 0 by 1 is nothing but 0. Now 0 0 we got in both the thing. That means alpha plus beta equal to minus b by a. Now alpha beta we will see. So alpha beta we can see that it is nothing but c by a. So no need to write c by a, we will just write it down. What is alpha into beta? Root 3 into minus root 3, that is 3 itself, minus 3. Now c by a is nothing but minus 3 by 1. It's nothing but minus 3 itself. So minus 3, therefore we can say that alpha plus alpha beta equal to c by a. So this is how you prove alpha plus beta equal to minus b by a. This is how you verify. Therefore verified. Now we will move on to the fourth one. Find the quadratic polynomial of the polynomial. The sum and product of the zeros are given. That means sum they give and product they give. Sum means alpha plus beta they give. Alpha plus beta they give. Alpha beta also they give. Now we have to find the equation, that is x square plus something x plus something, and here also something is there. So I am putting question mark for the something answer. So now we will solve how to find the something over there. So alpha plus beta is nothing but they gave it as minus 3, and alpha beta they gave it as 2. Now how we know that it is rather sum or product, and the number is sum or product? Because it is given sum and product. First is sum, so the first one will be minus 3. Product is second, so the second coming will the number coming will be 2, that is the product. So respectively means the accordingly. For example, minus 3 is the sum and 2 is the product. Now alpha plus beta is and alpha beta. Now we will write alpha plus beta is nothing but minus b by a equal to minus 3k they give, minus b by a equal to minus 3 by 1. So b by a is nothing but 3 by 1. So b equal to 3, a equal to 1. Now we will check with c by a. Alpha beta equal to c by a equal to 2 by 1, and c equal to 2 and a equal to 1. So now we will put it in the equation. We know that it is a x square plus bx plus c. So a is nothing but x, 1 into x square is nothing but x square itself, plus bx is nothing but 3x, plus c is nothing but 2. So it will be x square plus 3x plus 2. So this is how you got the equation. So now we will move on to example number 5, but example number 5 is not important in our for our syllabus. So we will move on to the exercise number 2.2. The first question: find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. So we have to verify as we already saw that what is verification, how it is solved. There are almost 6 questions, so after verifying all the 6 you can get thorough by this concept. So now we will look at the first one, x square minus 2x minus 2x minus 8. Now zeros of the polynomial first we will find, then we will verify it. So x square 8, if you sum means minus 4 and plus 2 will be there, and the sum will also be say correct. It's 2x minus 8, because minus 4 plus 2 is nothing but on sum it will be minus 2, and on product it will be minus 8. So by this equation we will, if we solve means minus 8, and now put it them in the bracket and take common outside. So x is common over here, and 2 is common over here. So x you take common means x minus 4 plus 2 x minus 4 x plus 2 x minus 4 equal to 0, x equal to minus 2, x equal to plus 4. Now alpha plus beta we will see. Alpha plus beta equal to minus 2 plus 4 equal to 2, and minus b by a is nothing but minus 2 minus into minus 2 by 1 equal to 2. So here we can see that alpha plus beta equal to minus b by a, hence verified. Now alpha beta alpha into beta is nothing but c by a we know, but we cannot write c by a over here, so we will write minus 2 into plus 4 minus 8, and c by a is nothing but c by a. So it will be minus so it is c is nothing but minus 8, and a is nothing but 1, so it will be minus 8 itself. So we can see that minus 8 and minus 8 are common, so it will be alpha beta equal to c by a. So here also we proved this, and here also we verified or proved this. So we can say that by this, that is take for example this is 1, this is 2, so hence verified. Now we will look at the second one, 4s square minus 4s plus 1. So now when you solve it will become 4s square minus 4s plus 1. So now 1 into 4 is nothing but 4, so you have to sum as now we will keep as sum as minus 2s and product as plus 1 itself, because minus 2 plus minus 2s is nothing but minus 4s, and minus 2 into minus 2 is plus 4, so 1 into 4 is nothing but plus 4. So by this we got this equation, and now we can take this as in bracket. So yes, you can take it as common, 2 and s you can take it as common, so it will become 2s minus 1 into 2s minus 1. Normally this should be equal to this, then only you can it will be easy for you to combine, otherwise somewhere you have made mistake. So 2s minus 1 and 2s minus 1, it's not necessary this and this should be equal to this and this. So 2s equal to 1, s equal to 1 by 2 and 1 by 2, because the other one also is there. And so sum of the zeros, that is alpha plus beta equal to 1 by 2 plus 1 by 2 equal to 2 by 2 equal to alpha plus beta. So 2 by 2. Yeah, so we will solve, it will be 1. And alpha plus beta, we can also call it as minus b by a. Minus b by a is nothing but minus into minus plus. No, so minus it will be minus into minus 4 by 4. So it will give us 4 by 4. Instead of minus into minus, into get plus. So I will write direct plus, so it will become 1. So this and this are equal. 4 by 4 is cut, so it will be 1. And alpha beta, that is product of the zeros, is nothing but 1 by 2 into 1 by 2 is nothing but 1 by 4. And alpha beta, we can also write it as c by a. So c by a is nothing but 1 by 4. So we got this and this are equal. That means that we have verified it. Now we look at the third one. 6x square minus 3 minus 7x minus 7x. Now we have to arrange it properly. For example, here it is minus 3, so here 7x is here. Normally we saw that 7x should be middle and 3 should be there. So we will arrange it properly, so it will become 6x square minus 3. Now 6 is 18. So what will be that? 4, 3, okay, so minus 7x and minus 3. And it will be 9 and 2. 6x square minus 9x plus 2x minus 3. So it will be 2x dx minus 3. 2x we can't take common outside, so it will become 2x, so it will become 3 plus 1 into 2x minus 3. So x equal to minus 1 by 3 and x equal to 3 by 2. So now I hope that you can verify by yourself. So now we will move on to next question, and the next 3 questions are homework questions, and after doing the homework, you please comment to me so that I can check it and correct your mistakes. Now we will look at the second part of the question, that is find a quadratic polynomial with the given number as the sum and product of the zeros respectively. So that means they gave the sum as 1 by, for some first one if you take means sum as 1 by 4 and product as minus 1. So we have to find a quadratic polynomial from these things. For example, first we will write what is alpha plus beta, or zeros of the polynomial. Alpha plus beta, they gave it as 1 by 4, and the product they gave it as minus 1. So now if we solve it will be x square, and alpha plus beta equal to minus b by a, so it will be minus 1 by 4 plus 1. So alpha beta they gave it as minus 1, so it will be minus 1. So write it again. Minus 1. So this one you can take it as LCM, and for this and this, so it will be 4x square minus 4x, and it will be x and minus 1 by minus 4. 4x square minus and minus 4. 4 square minus 1 square minus 4. Now we will look at the second question, root 2 and 1 by 3. Now here also it is given sum of the zeros and product of the zeros. alpha plus beta equal to root 2, that is minus b by a equal to minus root 2 by 1, and alpha beta equal to 1 by 3. So 1x by 3x is nothing but into 3 it will be, into 3 it will be. So it will be b equal to minus root 2, c equal to c is nothing but 3k, and a is nothing but and so we will, if we solve this means this actually we will keep it as another variable, no need variable, just we will leave it over like that. So if we solve means it will be x square 3x square minus 3 root 2, and this one we it is 1x by 3x, so we can keep it as 1 only. So it will be so it will be c equal to 1. So it will be 3x square minus 3 root 2 minus 1. So now we will look at the answer. And as we know that it is plus 1, so it will keep it as plus 1 itself, because here it is also plus 1. So this is how you solve the other question. Now we will move on to the third question. 0 and root 5. Alpha plus beta equal to 0. Alpha beta equal to root 5. And alpha plus beta equal to 0 equal to minus b by a. And alpha beta equal to c by a. So a we will keep it as 1, because here also 1, here also 1. So a we will keep it as 1. B we know that it is minus 0, it is nothing, minus 0 or plus 0 it will be nothing but 0 itself. And c we will keep it as root 5 itself. So we will be put in the equation ax square plus bx plus c, it will be x square, and since it is 0 plus 0 into x plus root 5. 0 into x is nothing but 0 itself, so x square plus root 5. So this is how you got the equation. It's not necessary that you have to solve that, you have to find that x also. It's not necessary, you have to just get the equation. So the equation is x square plus root 5. Now the other three questions are very simple and just follows the same step, and you can solve by yourself, I hope, after watching this video. And if you like this video, please subscribe, and if you want to share it, please share it. So in my next video I will be uploading the division algorithm for polynomials, in which we will be seeing about the divisions of the variables, and first time we will be seeing the division of variables, and we will see how to find the divisor, dividend or something else by using the formula that I am going to teach you in my next video. So thank you for now, and if you like, please subscribe it.